Hey guys, good morning. We are looking at day 11 notes here called midline and phase shift. So all that means is there other things that are going to affect the graphs and how they look and where they move and all that good stuff. Right? Before we jump into anything new, I want to remind you, anytime you're doing a trig graph, I want you to think that you have to plot those 5 points of the cycle. So as an example here, what you're being given on this first one is plain old sine of x. If you look at the graph, right, keep in mind there's more than one cycle, but if I just pretend I don't see that part over there, you see this one little cycle of the graph, the 5 anchor points. It starts at 0, it ends at 0 at 2 pi, dead center hits pi. So there's 1, 2, 3 of those anchor points. Halfway between 0 and pi, it hits top at 1, that's at pi over 2. Halfway between pi and 2 pi, you hit bottom at 3 pi over 2. Right? So make sure all 5 of those points get hit. That's important because as you graph these, they can't start just like roaming off into no man's land. So just throwing it out there as a little bit of Monday morning advice or whatever time or day you watch this. Okay, so all of these graphs are just basically in the form of, y equals a sine of b, and then x plus c and plus d. Of course, those can be pluses or minuses. And same thing for cosine, all right? So a is amplitude. We talked about that last week. B is frequency and how it changes the graphs, how it stretches it out or how it squishes it this way, all right? So it's saying consider the function of sine of x plus 3. So it says, how would the graph of sine of x be shifted to produce the graph of f of x? Well, hopefully you guys know enough that when we add something on the outside, that's a vertical translation. It's going to shift up 3. And let's say you're like, well, I didn't know that. Use your calculator. You could type this in, you could type that in, you could absolutely look at the comparison. Otherwise, you should definitely know this. So take every point, walk it up 3 units. So if I take this point at 0 and walk up 1, 2, 3, it's going to shift up. Here, if I walk it up 1, 2, 3, and you can keep playing that game all the way across. You know a vertical translation. It shouldn't change the shape. It's literally just shifting it to a new spot. So if here's my graph, and I can extend this back as well. So shift all those points up 3. There we go. So we're looking a little something like that. All right. So it says on the grid to the right, you've got y equals sine of x, sketch our f of x. So this is f of x here, right? And then on the graph, you sketched in part B, draw the horizontal line that splits the graph in half. All right, so the line that runs right through the middle of it, if we look, that would be like this guy right here. It's going right down the middle, all right? When it says, what's the equation of that line? Well, it's a horizontal line. So that means it's just y equals a constant. And the constant that it would hit, 1, 2, 3, is that value right there. Just y equals 3. So when we draw it, if you draw that line, draw it dotted, just because it's not technically part of the graph, but it kind of helps us keep the graph symmetrical and we know where the middle is. Right? So a couple things that we can say, I'm going to slide this up here, is it saying in general, the equation of the line that you drew above, right, is called the midline. And we mentioned that term in the vocabulary on the first day that we did trig graphing. It's always equal to whatever the vertical shift is of the graph. Right? And it can also be referred to as the average value of the function. And now, when you think average, you add some things, you divide by however many values there are. Well, in this case, what you would be averaging is you would average whatever the maximum and minimum values are of the graph, and then you divide by 2, since there's just 2 values. So like the example up above, if I take a look, I'm going to slide back up here for a second. The lowest value on our new graph would be this point right here, which is happening at 2. The highest point right here, happening at 4. They're just saying you average those 2 values. So if I come back down here, if I do 2 plus 4 over 2 really quickly, you can see, yep, there's that value of 3. So it would be y equals 3 is our midline. So if you're ever asked to calculate what the vertical shift is, and you have the graph already, that's a way to do it. Okay, so let's take it and look at it with some other details going on as well. So we have an equation. We've got f of x equals 2 cosine of x and then plus 1. So a few things. The number in front, that's the amplitude. So let's state that over here. So the amplitude is equal to 2. The number in front of the x, that's your b value, which is your frequency. And since I don't see anything, we know that that's a 1 right there, right? So you can even fill that in if it makes it easier to remember that, all right? And then in this case, we don't have a plus c going on the inside, which means the c part is a 0. What we do have is we have this guy out here, which is the d value, and that is the vertical shift or your midline, however the heck you want to say that, right? Oops, sorry, that's for this next section. Getting ahead of myself here. Ooh, shift that baby on down here. All right, the d value, that's your midline. That is going to be y equals 1. As for part A, it also asked us for the period. So reminder, the period or the length of one cycle is always 2 pi divided by whatever the b value is. So in this case, 2 pi divided by 1 means that the length of one cycle will just be 2 pi, just like it would normally be for the parent function. Okay, now it says sketch the graph from negative 2 pi to positive 2 pi. What's the range of the graph? So on. All right, so let's see if we can do the sketch. So how I would set this up is we are going to go from negative 2 pi to positive 2 pi. So if here's 0, this one is kind of nicely laid out that if you think pi over 2, pi, 3 pi over 2, 2 pi, it fits perfectly. All right. You don't necessarily have to label every tick mark, but it would help to at least label some of them. From here, because the period stays 2 pi, that means between 0 and 2 pi, I'm going to see one cosine curve here. Now, what else is going to happen? Well, it's going to be shifted up 1, and it's also going to be stretched out by 2. So what I'm going to do is I'm going to use my midline, and I'm going to sketch this first, all right? So after I determine whatever my scaling is, which is the label on your x-axis, right, the next thing you want to do is sketch the midline. Right? And we just draw it as a little dotted line. That's it. So come on up here at 1 and draw that in. The next thing after that I would suggest is then think about the amplitude. Right? So like in this case, the amplitude is 2. So cosine would normally start 1 unit above the midline. In this case, because the amplitude's 2, it's going to start 2 units above. If it helps, draw a little sketch of what cosine looks like off to the side. Cosine starts 1 above typically, and it finishes 1 above. Dead center, it's 1 below, and then it kind of looks like that. So let's adjust that to what we have going on over here. From the midline, I need to go 2 above. So I'm going to go 2 above and start here. That means it's going to finish over at 2 pi, 2 units above the midline. All right, come to dead center between those 2 points. That's at pi. It's going to be 2 units below the midline. So go down 2. And then halfway between, so halfway between 0 and pi, which is pi over 2, that's when it should hit the midline. Come over this way, halfway between pi and 2 pi, that's when it should hit the midline. There's my 5 anchor points. Do not sketch a curve until you've plotted those 5 points. So the start, finish, the middle, and then the 2 points at the halfway in between. So now I can sketch my curve from here. Because it says go from negative 2 pi to positive 2 pi, just extend the curve back. So that means here and here, it's going to hit a height of 2. It should hit that bottom there, 2 units below the midline, and then it should hit the midline halfway between 2 pi and pi, pi and 0, or negative 2 pi and negative pi and 0. Something you should notice already about cosine. Look at that. It folds right over that y-axis, which means a couple things. It means it has y-axis symmetry, but it also means it's an even function, right? And then the last part, it's asking you what's the range of the graph. So range, bottom to top. So take a look. The lowest value, that's -1. The highest value is at 1, 2, 3. And there we go, right? And now, could we have figured out the range without the graph? Definitely. We'll talk a little bit more about that in a moment. So step 4, I'm going to say plot those anchor points. It's not a high-tech term, but you got to make sure to hit those points. So you could call them the key points, the critical points, whatever you want. Make sure that you plot those points before you actually draw the curve. Okay. When we go on to the next page here. So it says here, as seen in the last example, the vertical translation along with the amplitude affects the range, right? So it says for the following trig functions, determine what's the amplitude, frequency, period, midline, and can you figure out the range without actually graphing it? Okay, well, let's try one. So first of all, the equation, here's the A, here's the B. I only jumped to calling that D because there is no plus C in the equation. If you want to call it C, go ahead, all right? Otherwise, amplitude, that's the 7 out front. So that means this graph would be stretched way up and down. B, the frequency. The frequency is simply the number in front of the x value. That's the 2. That means you would see 2 cycles between 0 and 2 pi. All right, the period, we can calculate it. It is always equal to 2 pi divided by the frequency. So in this case, the length of each cycle is pi, which hopefully makes sense because if I see 2 cycles from 0 to 2 pi, each cycle has a length of just pi. All right, part D, the midline. Well, there's a +4 off on the end, so that's going to be y equals 4. And now the last part, the range. So think about the graph. I can bring back the last one if I need to here. If here's the middle, think about how far does it go up and down from the middle? Well, it went up 2 and down 2, but what's that value? That's just the amplitude. So let's see if we can apply it here. The middle is at 4, the amplitude is 7. So if I take the middle and subtract the amplitude, and then do the middle and add the amplitude, that should get me what I need. So the middle's 4, but I'm going to go down 7. And then I'm going to go up 7. So that's going to drop me all the way down to -3 and bring me all the way up to 11. And I can actually think of the range just like that. The midline plus or minus the amplitude. So it should go from -3 up to 11. And we can answer that without even seeing the graph. For number 2, same type of thing. I'll let you guys try that one on your own. And you can check the answers on the website. Okay. What I would like to do is take a look at how do we graph this from start to finish now that we know all these pieces. This is where sometimes it can get confusing, all right? So with number 4, it says we've got -3 cosine of 2x and then +1. So we've got even a little something more that we don't always have, and that's the negative in front. If you remember, when we negate that value out front, that's a reflection over the x-axis. So we got a lot of stuff going on here. All right, let's answer all the things we just did a moment ago. The amplitude, remember that's always positive. So it'd simply be the +3 in front. The frequency, in this case, would be 2. So just like the practice one we just did a second ago, which means the period would be 2 pi over 2 or pi, right? So that's the length of one cycle. This is going to affect the x-axis scaling. It's good to mention it just right there, all right? And then our midline. Our midline is +1, so it's going to be y equals 1. Okay, just like I did on the last page, I'm going to give you the quick rundown of how I want you to think of this. Start by thinking of your scaling. You have to think about the period. You also have to kind of think about the amplitude along those lines, all right? Because you got to think about how far up and down is it going to stretch. And actually, you got to think about kind of all of it, if I'm being honest. One thing at a time. Let's talk about the x-axis. If one cycle goes from 0 to pi, then that's what I want to look at here, all right? So x-axis, we got to go from 0 to pi. Best bet is just draw your x-axis in the middle of the graph, and then you should have plenty of space to do whatever you want to do here. If you have a straight edge, bust it out. Otherwise, do your best to draw it kind of freehand. So here's my y-axis, my x-axis. So since I want to use as much of the graph as I can, space it out a little bit. So 0, maybe you even just spread it out like 1, 2, 3, 4, 5, 6, 7, 8. It's nice to use nice even numbers. That's helpful because when we go to plot those points, we're going to plot a point at the halfway mark. So right here, and then we're also going to plot points halfway between each of those. So even if you don't fully label them, give yourself those tick marks there. So the halfway again. Okay. From here, once you've got your x-axis scaled, I want you to sketch your midline. All right. So our midline at y equals 1. If you have a different color, use it. Otherwise, a dotted line works perfectly. We do have to determine the vertical scaling. I think to keep it easy so I don't confuse anybody, I'm just going to use scale of 1, meaning just 1, 2, 3, 4, nothing crazy. All right. If you'd like to expand on that, feel free. Just remember that you've changed your scaling. All right. So go up to a midline at 1. There we go. All right. And then from here, now I have to think about the amplitude, and in this case, the fact that we have a reflection going on as well. Mm-hmm. This, again, is a cosine graph. So I think it's a good idea, off to the side, sketch a basic cosine graph. It starts and finishes typically above the midline. Dead center, it's below the midline. Halfway between, it's on the midline. There's a basic cosine graph. All right, this baby is going to flip over. So it's going to start below the midline and finish below. Dead center, it's going to be above the midline, but it's still going to hit the midline halfway between. So because of our little reflection, I'm thinking about it in terms of my little red graph here. All right. The other things to think about, how far are we stretching it? So typically, it's only 1 unit below. Our stretch is 3, so I have to go 3 units below to plot my first point. So here's my midline, walk down 1, 2, 3, and plot that point. Because the period is pi, the cycle's going to finish over at pi. So 1, 2, 3 units below the midline, right? So that's where that 3 is coming in, is where I'd plot that point. Dead center, so go to the middle tick mark. You're going to go 3 units above the midline. So 1, 2, 3, plot that point. So now we've got 3 of the 5 anchor points. The halfway mark between here and here, it's symmetrical, is when it should hit the midline. So at this tick mark is where it should hit. Halfway between these two, halfway is where it should hit that midline. Now I've got my 5 anchor points, and there's 1 cycle of this cosine curve. If you want to label more of the tick marks, feel free. I mean, you know what halfway between 0 and pi is? That's pi over 2. Halfway between 0 and pi over 2 is actually pi over 4, all right? And then this would be 3 pi over 4. Do you have to label those? No, but I'm your math teacher, so I'm trying to help you out here, right? If you want to do this on your calculator, a couple of things. You have to make sure that you're in radian mode, and you'd have to change the window to match your scaling. So let me just show you this one time so you can see what I mean. So on my calculator, make sure that I'm in radian mode, which I am, okay? And then when I go up into the graph, let me get rid of that right there. I can type in -3 cosine of 2x and then +1. When I say I'm going to change my scaling, when I go to the window, you can use Zoom Trig, but it's going to give you a bunch of the cycles and you might not recognize what you're looking at. Specifically, this is going from 0 to pi, so 0 to about 3.14. And then my scaling, it's always good to use just scaling of, pi over 2 when in doubt. I know specifically that these tick marks are happening at pi over 4, so I'm going to use that. But don't overthink the scaling part. All right, and then look, I have mine graphed from -4 to about 4, but really it falls from -2 to 4. You can choose to leave it at that or switch it. I'm going to hit graph so that you can see it, but my goal is that I should see one cycle from 0 to 2 pi. And now, look at the tick mark. It's not hitting the x-axis there. What it should be hitting is the line y equals 1. So I'm actually going to plot in there the line y equals 1. And that's exactly what's going on. It's hitting the midline right there at that tick mark and at this tick mark. So we're looking pretty darn good there. Okay. If you were asked, what's the range? Well, the range goes from -2 to 4. All right, let's change it up just a little for the end of our notes here. It says determine the equation of the graph given here. So we've done a little bit of this. This time, though, you have to figure out, is it sine or cosine? And then what is, oops, sorry guys, I'm a little crooked here. There we go. What is the amplitude? The A. What's the frequency? The B. And then what's the midline? The plus D. Okay. From the other day, we talked about the fact that sine is when it starts on, I said the x-axis that day. Now it means it would start on the midline, since the x-axis isn't always the midline, right? Cosine is if it starts off of the midline. So to be able to determine this, you actually have to think about the midline first. So go at your graph, figure out where's the minimum value, where's the maximum value, find the halfway point, all right? So to find our midline over here, the lowest value this seems to be touching, -1, highest value, 3. So if I do -1 plus 3, oops, I'm sorry, I'm off the screen there. -1 plus 3 and divided by 2, my midline is right there at 1. And you might have said, I could tell it starts at 1. That's fine. Not everybody can always see it, so calculate it if need be. All right, there's my midline. So that value right there is 1. Now, look at the curve itself. And at 0, it starts right on the midline. So since it starts on the midline, this is a sine curve, all right? So now I know I'm going to have something, sine of something, x, and then plus something. Well, we know that part of it. That's 1. That's our midline right there. Mm-hmm. This is our amplitude. So take a look at your graph. How far does it stretch above or below the midline? Well, if it's going from 1 up to 3, that's a difference of 2 right there. So that is my amplitude. Mm-hmm. What you might have noticed, though, this graph goes down first, and then it comes up. That's an upside down sine graph, or it's been reflected over the x-axis, which means I need a negative, all right? And then last thing, how many cycles are you seeing from 0 to 2 pi? So 0 to 2 pi, that is just one cycle right there. And so that's going to be a 1, all right? Whew, there's a lot of stuff that goes into that, all right? So the fact that it's upside down gives us the negative. That's our amplitude, the stretch, how far it goes above and below the midline. That's the number of cycles you're seeing from 0 to 2 pi. And that is the value that runs dead center through the graph, the equation y equals 1. Okay, I think we've only got one left, but it's about phase shift. It's the only one that we talk about with phase shift because for the most part, we try to avoid having phase shifts. It just makes things easier if we don't have to deal with them, but we still have to at least talk about them. So it says the last transformation, the phase shift, which is a fancy way, right, of saying a horizontal translation or horizontal shift. So it means we're going left or right. You get it. All right. So let's at least play the game. If we break down these graphs, what's the difference between this guy And this guy, well, they both have an amplitude of 3, frequency of 2, and they both have a vertical shift or a midline of -1. If you look here, this one has a minus pi over 2 on the inside. This one does not. So the difference between them is going to be so that you can see the phase shift. All right, let's talk about the stuff that they have in common, though. The amplitude we just said was 3, frequency 2. That makes the period 2 pi over 2, or just pi. In the midline is y equals -1. I'm hoping that by the end of these notes, you can quickly be able to tell me the answers to all that stuff. Right? The phase shift for g of x, right? Well, what I want you to think about, anytime we have something inside the parentheses, it always is the opposite of how it looks. So if I see x minus pi over 2, that means that it's going to be shifting to the right pi over 2. If it was plus, that means it'd be shifting to the left. So what does that mean if I have a shift right of pi over 2? That's where I'm going to start the curve. So you're going to start the graph at pi over 2, all right? Where does the cycle end? Well, you have to consider what's the length of the cycle. That's called the period. The period's pi. So if it starts at pi over 2 and it ends at pi, you got to add that length on. That'll bring us up to 3 pi over 2. So that means instead of our graph going from 0 to pi, we just shift the whole thing over. It's going to start at pi over 2, and it's going to end at 3 pi over 2. And let's actually show those side by side. So for f of x itself, it's a plain old sine curve. Let's remind ourselves what a sine curve looks like. It starts at 0, ends at 0. It's 0 dead center, and then it goes up and then comes back down. Okay. So if we graph f of x has no phase shift. So it starts at 0. It finishes the cycle by pi, because that was the period. Dead center would be at pi over 2. Whoops, I just realized I forgot to think about the midline. Okay, good thing you can't see those points that well. Let's think about the midline. Whoo, come back down here. It's at y equals -1. Actually, let me make it in red so then you can see it a little bit better. I was trying to rush to finish up our notes for you. I gotta slow down. Okay, starts at 0 on the midline of -1, ends at pi, hits dead center at pi over 2. Halfway between these 2 points, it's going to go up 3 because that's the amplitude. So go up 1, 2, 3. Halfway between these 2 points, it's going to drop 3. So down 1, 2, 3. Okay. Sketch this first one. This right here, that's f of x. All right. The phase shift, you would technically take all those points and you would just shift them to the right pi over 2, right? So if I take this and I shift it to the right pi over 2, that's 1 tick mark on this graph. So that would come here. The point I'm standing on would jump over 1, and then this last point would jump over 1. All right, the max point, pop over pi over 2. Boom, there it is. Take the bottom point, jump over pi over 2. There it is. So what that means is my graph would look exactly the same, just everything shifted over. And that's what I mean up here by where does it start, where does it end? It ended up starting at that value of pi over 2 because that's where we shifted it to. Where did it end? Well, it ended up ending at 3 pi over 2 because we took where it started from, figured in how long it would be, and that tells me where it would stop. Okay, there you go. The phase shift is we're going to the right, pi over 2. We sketched them both so you can see them side by side. Ta-da! All right, guys, I hope you have a fantastic day. Make sure to stay on top of that homework and be on the lookout this week for probably a little Google form check-in from me. All right, thanks.